Did you know that it takes over 10 liters of fresh milk to produce just 1 liter of condensed milk? How is fresh milk transformed into the thick, sweet ingredient we all know and love? The answer might surprise you. Let's dive into the fascinating journey behind one of the most familiar products in your kitchen. But don't forget to subscribe to Captain Discovery to explore more intriguing production processes. The history of condensed milk dates back to the 19th century, when scientists sought ways to preserve milk for long periods without refrigeration. The process of condensing milk through heat helped retain its nutrients while removing over 60% of its water content. Condensed milk quickly became a staple ingredient in cooking and beverages, especially in Asian and Latin American cultures. Today, production methods still adhere to the foundational principles, but have incorporated modern technology to ensure quality and sustainability. So, where does the journey of condensed milk begin? The process begins at dairy farms, where cows are meticulously cared for to provide high-quality milk. Fresh milk is extracted using automated systems that ensure hygiene and efficiency. Immediately after extraction, the milk is cooled and stored in large tanks. Specialized tank trucks quickly transport the fresh milk to processing facilities, where each batch undergoes rigorous quality checks to meet the highest standards. At the factory, the milk is passed through pasteurization systems, where it is heated to high temperatures for a short period. This process eliminates bacteria while preserving the milk's natural flavor. To achieve the desired sweetness and optimal shelf life, sugar is added and thoroughly mixed with the milk. The sugar granules blend seamlessly, giving the condensed milk its smooth texture and signature sweet flavor. Next, the milk is transferred to large condensing tanks, where more than 60% of its water content is evaporated through heat. This stage not only increases the milk's density, but also enhances its natural sweetness. Can you imagine the rich, creamy aroma wafting from these tanks? The condensed milk is then moved to automated packaging lines. Cans or jars are sterilized at high temperatures to ensure food safety. The final products are carefully sealed and prepared for distribution, ready to reach kitchens around the globe. The production of condensed milk requires significant resources, such as water and energy, which necessitates thoughtful measures to minimize environmental impact. Today, manufacturers are striving to reduce their footprint by adopting water-saving technologies, recycling energy, and sourcing sustainable raw materials. Consumers can also contribute by recycling packaging and using products responsibly.
With global revenue projected to reach $4.2 billion by 2027, oat milk is rapidly becoming one of the fastest-growing alternatives to cow's milk. Brands like Oatly, Alpro, and Califia Farms are fiercely competing for market share in this booming industry. But how does a simple grain like oats turn into milk? In 1994, Swedish food scientist Rickard Osti invented oat milk while researching a more sustainable alternative to cow's milk. Instead of simply blending oats with water like traditional methods, he used biological enzymes to break down starch, creating natural sweetness without adding sugar. At that time, the plant-based milk market was still dominated by soy and almond milk. It wasn't until 2016 that Oatly, the company founded by Oste, boomed after entering the US market with a strategy targeting coffee shops. Chains like Starbucks began using oat milk for its perfect frothing ability, quickly helping it surpass soy milk in the barista industry. From a laboratory invention, oat milk has grown into a billion-dollar industry. But making a delicious glass of oat milk involves more technology than you might think. Let's step inside the factory to see what happens behind the scenes. Everything starts from vast oat fields in temperate climates. Oats take about 4 to 5 months to mature, and when the grain's moisture level reaches 12 to 14%, combine harvesters step in, collecting and threshing the oats on site. However, not all oats can become milk. Only grains that meet the standards for size, moisture content, and beta-glucan levels, an important soluble fiber, are selected for processing. At the factory, the oats go through a vibrating sieve system to remove impurities such as stones and sand. Next, a centrifugal dehulling machine gently removes the hard outer husk without breaking the inner grain. However, there's a challenge. The lipase enzyme in oats can cause the milk to become rancid over time. To prevent this, the oats are steamed at 90 to 100 degrees Celsius for 5 to 10 minutes, effectively deactivating the enzyme while preserving nutrients. After pre-processing, the oats are soaked in warm water, 45 to 50 degrees Celsius, for 2 to 4 hours to soften the starch. The mixture is then finely ground and transferred to an enzyme reaction tank. Here, amylase enzymes are added, working at 50 to 60 degrees Celsius to break down starch into maltose, creating natural sweetness without artificial sugar. After 30 to 60 minutes, the mixture develops a mild flavor, ready for the next step. After hydrolysis, the mixture still contains oat fiber, which can make the milk gritty. To remove insoluble fiber while retaining beta-glucan, protein, and minerals, the mixture is passed through a microfiltration system with 0.2 to 0.5 micrometer membranes. Nobody wants their milk to separate after just a few days. To prevent this, the mixture goes through a high-pressure homogenizer, 200 to 250 bar, which evenly distributes fat and protein molecules, creating a smooth and stable mixture. To ensure food safety while preserving nutrients, oat milk undergoes UHT, ultra-high temperature sterilization, heating it to 135 to 150 degrees Celsius for 2 to 5 seconds. At this stage, additional nutrients such as calcium, vitamin D, and B12 are added, making oat milk nutritionally comparable to cow's milk. Finally, oat milk is packaged in Tetra Pak cartons with 6 protective layers, shielding it from light, air, and bacteria. Thanks to this technology, the milk can be stored for 6 to 12 months without preservatives or refrigeration.
Imagine opening your pantry to find a tin of milk powder, a staple that can transform your coffee, enrich your baked goods, and even serve as a lifeline in emergencies. But have you ever wondered how this miraculous powder, which retains the essence of fresh milk, is made? Today, we're diving deep into the fascinating world of milk powder production, unraveling the journey from farm to shelf. Subscribe now and join Captain Discovery's journey. Milk powder's story begins in the early 19th century, when the need for a durable, long-lasting dairy product became evident. The first known production of milk powder was by Russian chemist Osip Krishevsky in 1802. However, it wasn't until the 1850s that the process gained commercial traction, thanks to the efforts of the American inventor, Gail Borden. Borden's innovation came about during a time of great demand for preserved food, especially for military rations and long voyages. Fast forward to the 20th century, and milk powder had become a global commodity, essential in various industries from confectionery to infant nutrition. The introduction of spray drying technology in the 1920s revolutionized the production process, making it more efficient and scalable. The journey of milk powder begins at the dairy farm, where fresh milk is collected. This milk undergoes rigorous testing to ensure it meets quality standards. Parameters such as fat content, protein levels, and bacterial count are assessed.
With knowing exactly what that experience is going to be like each and every time she comes through.
Do you remember your first visit to a farm? Share your memories in the comments below. The collected milk is then pasteurized, a process that involves heating it to a specific temperature to kill harmful bacteria without affecting its nutritional value. Pasteurization is critical for ensuring the safety and longevity of the milk powder. Fun quiz! What temperature do you think milk is heated during pasteurization? A. 145 degrees Fahrenheit. B. 161 degrees Fahrenheit. C. 185 degrees Fahrenheit. Leave your answer in the comments. After pasteurization, the milk is subjected to an evaporation process, where about 60% of its water content is removed. This is done using large vacuum evaporators, which operate at low temperatures to prevent nutrient loss. The resulting concentrated milk is much thicker and has a higher fat and protein content. Interesting fact: approximately 10 liters of milk are required to produce just 1 kilogram of milk powder. This concentration process is what makes milk powder so nutrient dense. The concentrated milk is then converted into powder form through spray drying. This involves spraying the milk into a chamber of hot air, where the tiny droplets dry almost instantly, turning it into fine powder particles. Spray drying is a marvel of modern engineering, ensuring that the milk powder retains its nutritional integrity and solubility. Spray dryers can process thousands of liters of milk per hour, making it a highly efficient method for large-scale production. The final step involves packaging the milk powder into airtight containers to preserve its freshness and prevent contamination. Each batch undergoes stringent quality control checks, including tests for moisture content, solubility, and microbial safety, before it reaches the shelves. The production of milk powder, like all dairy products, has a significant environmental footprint. It involves considerable water and energy use, as well as greenhouse gas emissions from dairy farming. To mitigate these impacts, many producers are adopting sustainable practices, such as water recycling, renewable energy sources, and more efficient farming techniques. Thank you for joining us in exploring the production process of milk powder. If you're amazed by the blend of technology and craftsmanship we showcased, like, share, and comment your thoughts below.